Okay guys, you took in a lot of information today, so here is your energy quick study. I'm going to go over everything we did today as quick as I can. So, energy definition describes the state of an object. It tells us how easy it is for an object to transfer energy, meaning doing work. It's our capability of doing work. Work is a transfer of energy. Now remember, energy just is a way we quantify the state of an object. Work is a transfer of energy by an outside force. If our force component and our displacement are in the same direction, we are adding energy. That's like if I decide to apply force to a box and make it move across the floor, then I would cause it to accelerate, meaning I would be giving it energy. If I was stopping an object that was traveling towards me, then I would apply a force in the opposite direction and remove some of its energy. Now, if an object is moving at a constant speed, the net force is zero. There is no work being done. If the object is not moving, the displacement is zero. Therefore, no work is being done. Kinetic energy is given by the equation 1/2 mass times velocity squared, and this is considered our energy of motion. If an object is moving, it has kinetic energy. This V is speed. It is not velocity, so we do not have to find components when looking at kinetic energy. Potential energy. We have two types: spring potential or elastic potential energy, and gravitational potential energy. Elastic potential energy is given by the equation 1/2 kx squared. K is what we call the spring constant or elasticity constant. The units are newtons per meter, and it tells us just how easy or difficult it is to stretch or compress a spring. Spring potential energy is given as U sub E for elastic, or sometimes it's written US for spring potential. Sometimes you will see EEL for elastic energy or ES for spring energy. These are all types of ways to denote or represent spring potential energy. Gravitational potential energy is when you have an object at some height relative to whatever initial position or reference line you want. So you can have a negative gravitational potential energy, or an object could have 0 joules of gravitational potential energy. The G is our gravitational constant, 9.8 meters per second, and I would say that this 9.8 meters per second only applies to Earth. So if we were looking at the gravitational potential somewhere else, I would plug in a different G. So understand that these constants are specific to whatever you're talking about. If I'm talking about a certain spring, then it has a very specific spring constant. If I'm talking about Earth, it has a very specific gravitational constant. If I was on another planet or the moon, it would have a different gravitational constant or gravitational acceleration. Now, potential energy, basically it's called potential energy because it's our most common stored energy. We say it has a lot of potential to gain kinetic energy. If I stretch a spring out, then when I let it go, that spring is going to start moving, and once we have motion, we have kinetic energy. So potential energy means it has the potential to move. Gravitational potential energy, if I'm holding something up at some height, I have the potential to let it fall and it gain kinetic energy. Thermal energy is what we consider the energy lost or dissipated by friction. This is written as EDIS or ETH. That's how we're going to look at thermal energy. Now, because work is a transfer of energy, force times displacement, thermal energy is equal to the heat created by a work due to friction. Okay, now friction creates that heat, so friction is our force, and delta X, of course, that is our displacement. This value is always going to be a positive because it is going to, friction goes against your displacement. So really, it would be like a negative work, but because it's a negative work due to friction, it is, you can kind of think like Newton's third law, it's a positive heat gained due to friction. So this value is going to be positive, and we need to think of it as heat gained instead of work due to friction. Now, we have Hooke's law. Hooke's law is very simple. It discusses pretty much everything to do with a spring. It looks at the relationship between the spring force, how much the spring pulls on whatever object it's pulling on, to the displacement of the object from an equilibrium mark. So normally a spring is set to have some equilibrium, and that means it's just it's happy, it's not going to move at all, it's in equilibrium, and that's called its equilibrium position. Now if you stretch that spring out, then the spring's pulling back. Okay, it's called a restoring force. It's trying to pull back to get it back to equilibrium. Here we have if you compress the spring, okay, again, it's trying to restore the object back to equilibrium, restore the spring back to equilibrium. That's where this negative comes from. The negative just says it's a restoring force. And so if I were to compress it with a negative displacement, then I would have a negative K times a negative X. So that double negative indicates a force to the right. That's what the negative means. Here, if I move a positive displacement, then my spring force is negative, or to the left. Again, negatives in physics most of the time just mean direction. So that's pretty much all we have with energy. All you need to know up to this point about energy. Go over that again. Make sure you know these definitions,